Hello everyone, I'm Jay, your host at Everything Cloud Platform. Welcome to this session on making our GCP apps production ready. We'll need to do a lot more than what we have done so far to make our app production ready. For example, we'll need to design for scale. Currently, our Apache web server is running on a single VM. What if that VM goes down? What if the service, the Apache 2 service on the VM goes down? That takes our application down. That's not good. We'll need to make these VMs stateless so that if one VM dies, you should be able to bring up the other VM and your application should just start getting served from the newly created VM. We'll need to look at how we incorporate IAC, for example, or some security postures that we'll need to do. So let's go. Here is what we'll be doing in this session today. We'll look at the top 10 best practices of modern app development. We'll then apply some of those practices right here in this session. For example, we'll create instance templates, MIGs, and load balancers to access our Apache web server. We'll walk through of 10 stages of maturity of running apps in GCE. We'll then make some observability enhancements like notification channels and alerting. Let's walk through the 10 best practices for modern app development, and this is based on one of the Google Cloud Next YouTube videos that I came across earlier in 2023. If you click that link, you will be taken to this YouTube page, YouTube video that talks about 10 best practices for modern app development, and this is a Google Cloud tech video. And this was one of the breakout sessions during the Google Cloud Next earlier in 2023. A very good reference video. The first one here is designing stateless services. Your services that you build should be stateless, meaning if the instances go down at any given point in time, you should be able to just bring up another the other instance with the same setup, and your application should just be running seamlessly. That's what stateless service means on a very high level. Then you should be designing for scale. Currently, if you think about our VM Debian, that's a standalone VM. If that goes down, or even the Apache service goes down, your website is down. That's not a good design, right? So you will need to design for scale. If the load increases, then you should be able to auto scale up, right? You should be able to scale up and down based on the load on your application. Of course, infrastructure as code, Terraform. You should be. We have not done that yet. So that's another key best practice that you should be including. Security, overall security of your application, right from start to end. Things like least privileges, etc., that you should address. External IPs, not a good practice, so we'll get rid of the external IP. Observability, we have done a lot. There are a couple of opportunities, if you will, that we should be addressing. For example, alerting, notification channels, etc. Then you should have visibility to your costs, because with cloud, since the resources are infinite, if you don't have proper mechanisms to manage, track and manage your costs, you could actually be hurting yourselves from finance standpoint. Optimize your containers. Well, it does not apply to anything we are doing in GCE in this use case. We'll touch upon that in future sessions. Cloud native pipelines. Currently, you should have some form of CI/CD built in, and wherever possible, use cloud native pipelines. For example, in Google, we have something called Cloud Build that you should be using to build your CI/CD pipelines. Use managed service as far as possible. For example, Cloud Run is the managed service to run containers. Like rather than running a container on, say, GCE on your own infrastructure, maybe use Cloud Run to run your containers. BigQuery is another example of using a managed service database, data warehouse solution from Google Cloud. And then cloud-based development. Everything you do, you build your applications with this. You design your solution with this prefix in mind that you're doing a cloud-based development. So of these 10 features, on the left-hand side is what are more appropriately applicable to the use case that we have been tracking in these sessions here, and running our Apache server on GCE and Grafana running on GCE. So we'll make them stateless. We'll design for scale. Infrastructure as code, we'll get there as well. Supply chain security will implement a couple of things, like we'll get rid of the external IP. Observability, we have a lot built already. We have built the golden signals dashboards in both Grafana as well as native GCP. We will bridge a couple of gaps that we have identified. When you talk about building stateless services and designing for scale in GCE, Google Compute Engine within GCP, managed instance groups is the solution you're looking for. So if you go over designing your application using managed instance groups, we call them MIGs as well. This gives you all of these benefits as you see called out on this page. These are stateless serving workloads. It gives you high availability. It gives you all of these features that you're seeing called out here, scalability, etc. And you should look at this page in depth. That will give you a very good understanding of how do you make your applications scalable and reliable in Google Compute Engine. I would point out this page here that gives you some quick ways of building your architecture diagrams, and I would want to point out one specific architecture diagram that is relevant for what we are trying to do here. So if you look at this diagram, currently we were running our Apache web server on a standalone VM. What now we are going to do is we'll have a MIG running like this with multiple instances of our Apache web server running in the background, and then we'll have an HTTP load balancer that actually uses this managed instance group as the backend, and the requests that we hit, the load that we hit via this load balancer will get distributed across all the instances behind this managed instance group. That's the architecture that we are going to deploy here. That will make our application both stateless as well as from scalability standpoint will be good. The way the MIGs work are you will need to have an instance template created. Instance template basically is like we created our VM Debian. Using the same startup script, we'll create the instance template first, and this instance template is used by the managed instance groups. Then we'll come here and create the instance groups. When you go about creating the instance groups, it asks for a template. See this? So you need to create the instance template first. Basically, that will be the blueprint of the VM Debian machine that we have been using. We'll have the same startup script that created the VM Debian machine with all the installations like the Grafana, Apache server, the monitoring ops agent, and so on and so forth. So those are the two steps that we'll do, and I already have the bash scripts like what you see in the last few sessions around how we automated. That's what we'll do for instance template as well as creating the MIG. I'll walk you through what these scripts are doing, and then we'll run the script. So the first script that we'll run is this create instance template, and after setting some variables, basically this is running this gcloud compute instance template create template name that you have defined in the config file. That's the template that we are going to be creating, VM Debian instance template. Now if you look at this is exactly similar to how you create an instance. It's just that this is going to create a template, and notice that this is using the same startup script that we used to create our Debian machine. That's our template. And on the right hand side, now if you look at create MIG, there are three steps that you will be doing if you do create a MIG via your bash scripts. So after creating your instance template, now you're ready to create your MIG. And on the right hand side you have the create MIG bash script. So when you create a MIG from the console, in the background it actually creates these three things that you can individually create here. So the first one is a health check. You will need a health check. That is a required scenario for MIG. So we'll create a health check that basically is the health check to the TCP port 80 on for the Apache server up and running. Right? That's our health check. Then you actually go about creating a MIG that uses the template that you created with the bash script on the left. This is the parameter that specifies that template, right? This is the MIG Debian template that we have provided in the config file. If you look at the MIG Debian template, that basically is the template that we just created from the left hand side, right? And then the third thing is creating that auto scaling policy. Basically this auto scaling policy, if you look at the parameters, that is saying that I'll need a minimum of 2 replicas and max replicas are 3, meaning if there is load that these two cannot handle, then GCP will create one more node, bring one more node up and running to handle the additional load. So those are the two scripts that we are now going to submit to create the instance template and the MIG. Let's go ahead with submitting the create instance template, right? That's the bash script to create the instance template. All right, there you go. Our instance template got created. If you want to take a quick peek and look at this instance template, this is where you will find it. So if I navigate to compute engine instance template, you will see that our instance template got created and is showing up here. If you get inside and look at this, see these labels that we provided, that's the name that we provided in the bash script. And I'll point out at this point the startup script. That's important, right? This is the startup script that we have used, right? All the steps, like you see, that's our Google monitoring ops agent. This is the configuration file for that monitoring ops agent. This is the Apache web server installation. And this is the Grafana installation, right? So that's our instance template. Now we are ready to submit the create MIG. Now watch as we create the MIG here. So there are 3 steps that will occur like we discussed. First is the health check, and that's our Apache server health check that is created. Now it's creating the MIG. Let the MIG come up, and then the third step would be to have the auto scaling policy in place. So the MIG got created. Now this is setting the auto scaling policy, the third step. Once this is completed, your MIG is up and running. All right, everything got created well. We'll go back to the console and validate that all of this was indeed created. So I'll navigate to instance groups here. That's my instance group, and if you look at this instance group, yeah, that is getting created now. So if I look at the MIG Debian, yeah, this is not up and running yet. It's not healthy as VM is being verified, because notice that we have the startup scripts and they are not run yet. Of course, the health check is not healthy as well, because Apache is still getting installed, right? We have all the startup scripts as the VMs are brought up. These are the VMs behind this managed instance group. You will be able to SSH into these and run the journal CTL commands, and we'll get into that and do our little validations. Let's give it a few minutes while the MIG is completely up and running, and we'll then perform our validations. Our MIG is up and running and is healthy now. Everything looks fine here. The health check status is good. The MIG, both the machines are running fine, and you can just look at all the details in here. We'll now do our validations from the terminal as well. Now I just pulled up all the VMs using my gcloud compute instances list command. That is one. The other one is this. Notice the last four characters. That's how MIG differentiates between those two VMs. Now notice that they do not have external IP, right? Our original VM Debian has the external IP. And this was one of the security practices that I mentioned in our opening comments as well. If you notice in our config file, there is one change that I have introduced when we were creating the instance template, and that change is this. If you notice the network interface value in this, I have added this no address, and that's the parameter that results in our VMs not getting an external IP, and that is one of the best practices that we should include. You should not be allowing any direct hit to your instances behind the MIG. So that's what we have accomplished with this. Now we will SSH into these two. On the left hand side, we'll SSH into W3VL. So let me do my SSH here, and 0ZML will SSH on this side. All right, we have SSH'd into both the instances behind the MIG. Let's do a clear screen on both. And how will we validate whether every step in our journal CTL in our startup script completed? Yeah, use journal CTL, because we are posting really good comments in there with the tag startup script. That's what I will use here. All right, and I'll do the same thing here. Journal CTL -t startup script. All right, now let's make this screen bigger and look at all the steps. Google monitoring ops agent, all successful. Apache web server, all successful. Grafana, all looking good. And we know this from last time as well. Listing of available packages was failing, but it does not impact really anything. That maybe is food for thought for you guys to figure out why. All right, and now we'll do the same installation on the same validation on the right hand side. Everything is good with this, with Apache web server, with Grafana installation, absolutely same result on both the sides. So we're good from journal CTL. But let's do our validations by actually hitting the servers as well and validating the service. So system CTL, let me clear the screen. System CTL status Apache 2. That's our service running up and running fine, all good. We'll do a system CTL status on Grafana server 2, and that is running fine too. We'll do a curl local host. That should bring up our index.html with the internal IP of this particular MIG. This is 0.19. You will see a different IP on the left hand side, and we'll get there soon. We'll do a curl on port 3000, and we should see this /login. So that is also fine. We'll do the same validations on the left hand side. Clear the screen. We'll do a system CTL status Apache 2. Then we'll do the same on Grafana server. That's fine too. We'll exit out of this. We'll clear the screen. Now we do a curl local host, and that should give a different IP. This was 0.19. This is 0.18. And then we'll do a quick curl on 3000. All right, everything is running fine. Now, how do we access the MIG? That's the next part that we are going to identify. The next step is to expose these VM, the Apache web server, to the external world. Currently, there is no external IP of the instances behind the MIG. So there is no way you'll be able to hit your Apache web server from the outside world. You cannot use the internal IP to access that. You will need an external IP, and you do not have that. What we'll then do is to create the HTTP load balancer that uses this MIG as the backend, and hence and this HTTP load balancer will have an IP that you will be able to use to hit from the outside world, right? That's what we are going to do next. So if we navigate to network services load balancing, that's what we'll use to go ahead and create our load balancer. So let's start getting start creating the load balancer here. Use the application load balancer. That's what we are going to be creating here. Start the configuration, leave all the defaults in here. All right, so the first thing is the front end configuration. Let me name this LB Debian, right? LB Debian. My front end configuration is, say if I say this is my Apache web server. This is my front end Apache web server. This is my front end for Apache web server. And I'm saying, yeah, I created this external IP one IP. Well, I have reserved one IP already that we will use for this purpose now, and we'll be hitting at port 80 of this IP. So that's our front end configuration, right? That becomes our front end that the outside world will be able to use to access the Apache web server. Now we'll do our backend configuration. Our backend configuration is going to be that MIG. So at this point, we do not have a backend service yet. We'll go about creating a backend service, and we'll call this backend service for our MIG Debian, right? So I'll say backend service for MIG Debian. And we are saying the backend type is an instance group, and you could have these multiple options. We'll go with instance group for here, and leave everything else default, and our instance group is showing up here, and port numbers will say 80. That's where our Apache web server is running, and that's important, right? This is where our Apache web server, if we are not opening this, that will be a problem. All right, leave everything as it is. We'll use the CDN. CDN is basically your content delivery network. This is the caching mechanism. Let that remain enabled. Now health check. Remember, we created health check as well as part of our backends, the bash script, and that health check was called Apache server. We'll use that one here. We'll enable logging, so we get all the information in logs. We will use, I think we are good. We'll just go ahead and create. Okay, so that creates the backend service. Routing rules, just leave as it is, just default. This is basically if you want to include a path-based routing to different HTML pages that you must have built. Basically, some advanced configuration that you want to do based on URI paths and so on and so forth. That's not what we are doing in this session. So we'll move forward, leave this as is, and we'll do a quick review and finalize. We have the front end, we have the routing rules, we have the backends, and now we are ready to go ahead and hit create. It takes a few minutes to get the load balancer up and running. So it is up and running now. Let's do a quick validations here. If I click at the LB Debian here, that's our IP. That's the IP that we will be using to hit our Apache web server, and we'll soon see how. I'll just copy it in my clipboard. Routing rules, backend services, everything is looking fine. Our health checks are running. Our load balancer is ready to take traffic now. Here at this point, I'll have you go through this monitoring. This will tell you how the service, how the traffic is making its way to the backend service, right? That's what this quick monitoring diagram tells you. If I hit that load balancer IP that brings up our server. Notice that the response is coming from 0ZML, which is the 0.19. But if you keep on hitting, see that now it's getting load balance between two. This response is from 0.18, the other MIG that we have. So if you do that multiple times, you'll see that sometimes it's a round robin and you'll get responses from both. Now what we'll now do is just induce some load on this IP, and we'll see some of this in our Grafana chart, and that's why I'm inducing the load. So if you do a while loop, and this is the IP is going to be this. Let's just get started with running the load here, and on the right hand side we'll induce some errors right on this one as well. I'll go ahead and change this IP to make it the load balancer IP, and we'll keep introducing some errors. Notice on the left hand side, sometimes you'll see response from 0.18, sometimes from 0.19. That's how it is going to work. We saw Terraform called out as, or infrastructure as code called out as one of the top 10 best practices for modern app development. For everything that we did so far, if we want to terraform it or apply infrastructure as code in the right way, I suggest you go through my Udemy course that is available online on Udemy today. It's one of the top rated courses out there that walks you through the 10 stages of maturity of running applications in GCE. If you navigate to udemy.com and search for GCE reliability, you'll come across this course. And that is a top rated course, as you can see. And if you go through the agenda, it walks you through 10 stages of maturity of running applications in GCE. And here is what those 10 stages look like. The course starts at level 1, at stage 1, at novice level, with manual actions via GCP. So we create infrastructure using manual actions. It then progresses through these stages. We enable logging, then we use startup scripts, then we do complete automation using bash scripts. Then we build automation using Packer built images. We then introduce IAC, provisioning infrastructure using Terraform. We then create instances using instance templates. We then apply reliability engineering principle to avoid single point of failures by introducing managed instance groups. We then implement a load balancer. We then configure important networking concepts like Cloud NAT and DNS. End of the course, you would have gone through a complete cycle of how you go about running a production grade application. All the Terraform code that the course talks about is available in this public Git repo that you can access, clone, and really customize for yourselves. This is available, and the course talks about all of this. If you look at Terraform, these are the stages. Look at all of these stages. The final stage is stage 10 that has this MIG, LB, like every component that we talked about here is built using Terraform. For example, this load balancer, take a look at this. This is talking about all the code that creates the load balancer. This is the code that creates the MIGs, and so on and so forth. In the top 10 best practices for modern app development, and as an SRE, this is one of the most important features or best practices that you should go after. We need to build some alerting around our traffic and errors. That's not that's something that we haven't done yet. Let's go about seeing how you will be able to build some quick alerting around your traffic and errors. So if you go to monitoring, within monitoring you will see this alerting, and keep in mind all of this can be done via Terraform as well. Go through that GC Udemy course and you'll see some of that, but let me create some of this manually. I'll go ahead and edit these notification channels, and I'll provide, say, my email address. I'll just say Jay. All right, so that's the now we have a notification channel available. Now we'll go about setting some alerting here. If I go back to alert, let's create a policy. We'll use the log based metrics, say request total, to set up our alerting. Now what we are saying here is, for the log based alert, in the rolling window of say last 1 minute, if my rate, let's add some condition here, right? If I say my rate goes beyond say 2 per seconds, I need an alert, right? So if I go about setting this alert, I'll say next, and I'll say threshold. It goes, so if it goes above threshold, and threshold value is say 2 per second, right? That's my threshold value. So I'm saying if I induce like this one, I just hit the load more, and this went beyond the 2 second limit. We'll do the same, and we'll see the alert getting generated. So basically, I'm saying if my request rate goes beyond 2 per second, I should get an alert. So that, and my notification channel is J. I say okay. I'll say request rate above threshold. Notify incident on closure. Policy name, request rate. That's my policy name. All right, I'll say create a policy. Now let the policy creation complete. Then the policy is created. Let's see, everything is fine right now because we haven't really seen any high requests yet because our threshold is controlled. Let's induce the load. What I'll do is I'll burst this. Now earlier in our while loop, if you see that we were sleeping, we were waiting for so many seconds before we hit the next iteration. Now in this for loop, we'll just brute force hit our public IP of the load balancer for like 1,000 times, right? That's what we are doing. Majority of the time the response is coming from 18. Sometimes you will see .19. Yeah, that changed for a little bit. Majority of responses are coming from 0.19, and that's what we'll see on the Grafana dashboard here as well. Let this run for 1,000 times, and let's see if we got some alerts getting generated. Here we are on the alerting screen. Yep, our alert just got fired, and take a look at this incident. That's the incident summary, and let's look at what the incident says here. Yep, that says, yeah, in this 36 seconds, yeah, I got and this is pointing to this, right? It is telling you the duration when that occurred. It's giving you some really good information out here on what happened. So you just got the incident created. And here is the email that we received to the notification channel that we set up, right? We got that email delivered to my email ID, and it talks about what the error is. Look at the subject line that says request rate above threshold. That's what we configured in the alert policy, and it's giving you all the information. It's giving you what is wrong. Basically, it's saying it's above the threshold of 2 with a value of 5.417. That's what happened. In similar fashion, you can just go ahead and create an alert for your errors going beyond a certain level as well. That I'll leave it up to you. Do your homework and create similar alert for errors going beyond a certain threshold. A quick look at how our Grafana dashboard is holding up here. You see these two spikes? Yeah, those are the two spikes when I induce the load without the sleep between the two iterations. That was the load. This was the one that we saw the incident getting fired on. We built the notification channel somewhere here, and that's how we were, and the alerting policy here. That's how we were able to see the alert getting fired. So our Grafana dashboards are just running fine. We saw the golden signals built up. That is just showing on the dashboards really well. At this point, we'll take a quick peek at the Google native dashboarding that we built as well. We'll go to the dashboards. We'll bring up our golden signals dashboard and take a quick look at that as well, and that should be showing these two spikes here as well. If I just, yeah, this is the last 1 hour, and this is showing the appropriate spikes as you are seeing in the Grafana dashboard as well. Let's touch upon the FinOps part a little bit. In the GCP free tier initial bootstrap session that we discussed, we talked about setting up the billing export and having the billing information available or exported to BigQuery. So we have the billing information showing up in the tables here. Look at this preview. You have all the detailed data, and I provided this query as well that pulls or extracts the information in a nice way by services. So this quick query is telling you that of my $9 spent, or as we were doing these sessions, here is the breakup of how the dollars were spent. Majority of this, since we have been using everything in GCE, that's why you're seeing majority of the cost here. But say if you had a heavy usage of BigQuery or cloud storage or any other services, that would have appropriately shown up here. And based on your use case, you should be able to look at this table, do a preview, look at all the fields that are available, and appropriately modify the query to pull the information that you want to pull. And then you can of course use Grafana or say Data Studio or Looker Studio or any other visualization tool to really put this information in a nice charts that your finance teams should be able to use the information for to control the costs and appropriately manage FinOps. Here's the recap of what we did in this session. We implemented 5 of the top 10 best practices for modern app development as suggested by Google in the Google Cloud Next video. That's the link for which is pasted in here. We built or implemented MIGs that gives you the stateless services features and design for scalability. We talked about how you can implement infrastructure as code. We talked about taking out the external IP and hence strengthen your security. Of course, this does not cover everything with security. Security is a vast topic on its own, but at least the least privileges, using the right service accounts with the least privileges and not having the external IP exposed to the outside world, and so on and so forth. So those are some basic features that you should have in place. We looked at all the observability in Grafana, and we looked at how we go about setting up the alerting, monitoring, alerting and notification channels. Some of these container stuff we'll look at this when we cover these demo applications in GKE. Well, that brings us to the end of this video on making GCE application production ready. If you like the content, please do subscribe to the channel, hit the bell icon to get notifications when new videos are posted. If you're genuinely interested in learning all the foundational skills we have been looking at on Everything Cloud platform, stick around and follow along all the videos posted. I'm sure you had a wonderful time here, and I'll see you in the next session.